Hello, good day everyone. Welcome back to our discussion on the topic quadratic equation. And today we will be discussing completing the square method. Completing the square method. Now, the complete the square method is used to solve quadratic equation of the form ax squared plus bx plus c equals to 0. It is normally used when we cannot solve the quadratic equation using factor method. Now, we are going to be breaking this down in steps so that it will be easier to follow. Now, for the first step is to make the coefficient of x squared to be equals to 1. That is, if a is not equal to 1, divide the entire equation by a. And when we do that for our example, that's ax squared plus bx plus c equals to 0, it becomes x squared plus b over ax plus c over a is equals to 0. Now for the step 2, we move the constant to the other side. So moving the constant to the other side, our constant is c over a. It becomes x squared plus b over as is equals to minus c over a. Don't forget our sign when moving constant. Now the third step is to add another constant to our right hand side to make it a perfect square. And to make it a perfect square, the number we are going to be adding is b over 2 square, and we are going to be adding it to both sides to keep the expression mathematically correct. So adding b over 2 square to both sides, in this our question, our b is b over a, and b over a divided by 2 and squaring it to be b divided by 2a square. So it becomes x square plus b over as plus b over 2a in bracket square is equals to minus c over a plus b over 2a in bracket square. Now at this step we can easily factorize our left hand side. So our left hand side will be s plus b over 2a in bracket square, which will be equal to whatever our value is in our right hand side. So we're going to be representing our right hand side with RHS for simplicity. Now the next step, which is our step 5, is to take the square root of both sides, and taking the square root of both sides, it becomes s plus b over 2a will be equals to, since we're taking the square root, we know we're going to be having two values, that's a positive value and a negative value, to be equals to plus or minus the square root of our right hand side. So making a the separate formula, s will be equals to minus b over 2a plus or minus the square root of our right hand side. And taking the sign singly, our s1 will be equals to minus b over 2a plus the square root of our right hand side, or our s2 will be equals to minus b over 2a minus the square root of our right hand side. Now this is going to give us the true value for x. Now we have an example that states that solve the equation x squared minus 5x minus 1 equals to 0 by completing the square method, leaving the roots correct to one decimal place. Now we were told to use completing the square method. Now for our solution, the coefficient of x squared is already unity, or it's already 1, so there will be no need to be dividing. So we going to be x squared minus 5x minus 1 is equals to 0. Next, we are going to be carrying the constant, that is minus 1, to the right hand side, and doing that it becomes s squared minus 5s is equals to 1. At this point, we are going to be adding the square of half the coefficient of s to both sides, that is to make the left hand side a perfect square. Now here the coefficient of s is in minus 5, that is half of minus 5 square will be equals to minus 5 over 2 in bracket square. So adding that to both sides of the equation, it becomes s squared minus 5s plus minus 5 over 2 in bracket square is equals to 1 plus minus 5 over 2 in bracket square. At this point, we are going to be factorizing our left hand side, since we completed it a perfect square. And factorizing the left hand side, it will be s minus 5 over 2 in bracket square, because our two factors will be minus 5 over 2, which equals to 1 plus 25 over 4, which is equals to 29 over 4. Now the next step is to take the square root of both sides, and when we take the square root of both sides, it becomes s minus 5 over 2 will be equals to plus or minus the square root of 29 over 4, which will make s minus 5 over 2 to be plus or minus the square root of 29 divided by 2 because the square root of 4 is 2, so we can remove the 4 from the square root. So s will be equals to 5/2 plus or minus the square root of 29 divided by 2. Now for our two value of s1 will be equals to 5/2 plus the square root of 29 divided by 2, and s2 will be equals to 5/2 minus the square root of 29 divided by 2, which will be equals to, for s1, 10.4 divided by 2, which is 5.2, and for s2 it will be equals to minus 0.4 divided by 2, which is equals to minus 0.2. So the two value of s is 5.2 and minus 0.2. We have another example that states that solve the equation 2s squared plus 3s minus 8 is equals to 0 by computing the square method. Now writing out our equation 2s squared plus 3s minus 8 equals to 0, our first step is to make the coefficient of s squared 1, and we are going to get this by dividing through by 2. Now dividing through by 2, it becomes 2s squared divided by 2 plus 3s divided by 2 minus 8 divided by 2 is equals to 0 divided by 2. So it becomes s squared plus 3/2s minus 4 is equals to 0. The next step is to carry the constant, and when we do that, it becomes s squared plus 3/2s is equals to 4. Now we are going to be completing our square, that is adding a constant to our left hand side to make it a perfect square, and the constant c will be equals to b/2 in bracket square. Our b in this case is 3/2, and 3/2 divided by 2 will be 3/4, and when we square it, c will be equals to 3/4 in bracket square. Now adding 3/4 in bracket square to both sides of the equation, it becomes s squared plus 3/2s plus 3/4 in bracket square is equals to 4 plus 3/4 in bracket square. At this point, we are going to be factorizing our left hand side, and we know that our factor will be 3/4. So factorizing our left hand side, it becomes s plus 3/4 in bracket square will be equals to 4 plus 9 divided by 16. That's the value of 3/4 in bracket square. So it becomes s plus 3/4 in bracket square, and when we add 4 plus 9 divided by 16, it gives us 73 divided by 16. At this point, we are going to take the square root of both sides, and when we take the square root of both sides, our left hand side loses its square, so it becomes s plus 3/4 will be equals to plus or minus the square root of 73 divided by 16. The square root of 73 divided by 16 will be the square root of 73 divided by 4, because 16, the square root of 16 is 4. So s will be equals to minus 3/4 plus or minus the square root of 73 divided by 4, which when simplified further will be equals to minus 3 plus or minus the square root of 73 divided by 4, because our denominator is 4 for both parts of the right hand side. So for our value of s1 will be equals to minus 3 plus 8.54, that's the value of root 73 divided by 4, and our s2 will be equals to minus 3 minus 8.54 divided by 4. Simplifying, s1 will be equals to 1.4 and s2 will be equals to minus 2.9. We'll be treating one final example from WAEC 2001, and it states that solve the equation 2s squared plus 7s plus 2 is equals to 0 by completing the square method. Give the answer to 3 decimal place. Now writing down our equation 2s squared plus 7s plus 2 is equals to 0, and our first step is to make the coefficient of s squared 1, and to achieve this we are going to be dividing through by 2. Now when we divide through by 2, it becomes 2s squared divided by 2 plus 7/2s plus 2 divided by 2 is equals to 0 divided by 2. Simplifying, it becomes s squared plus 7/2s plus 1 is equals to 0. Now our next step is to carry the constant to the right hand side, that is carrying plus 1 to the right hand side, and when we do that, it becomes s squared plus 7/2s is equals to minus 1. At this point, we are going to try and complete our square by adding a new value for our constant c, which will be equals to b/2 in bracket square. Our b in our question is 7/2. Dividing it by 2 will be 7/4, and squaring it, c will be equals to 7/4 in bracket square. Adding the value of c to both sides, it becomes s square plus 3 over 2s plus 7 over 4 in bracket square is equals to minus 1 plus 7 over 4 in bracket square. Now we can factorize our left hand side, and we know that our factor is going to be 7 over 4. So factorizing the left hand side, it becomes s plus 7 over 4 in bracket square will be equals to minus 1 plus 49 divided by 16. So simplifying the right hand side, it becomes s plus 7 over 4 in bracket square is equals to 33 divided by 16. At this point, we are going to be taking the square root of both sides, and when we take the square root of both sides, it becomes s plus 7 over 4 is equals to plus or minus the square root of 33 divided by 16. We should make s to be equals to minus 7 over 4 plus or minus root 33 divided by 4, because the square root of 16 is 4, so we can simplify our numerator in that part of the expression. So this will be equals to minus 7 plus or minus the square root of 33 divided by 4. So the value of our s1 will be equals to minus 7 plus 5.745, that is value of root 33 divided by 4, or s2 will be equals to minus 7 minus 5.745 divided by 4. That we are taking each of the sign separately. Simplifying, s1 will be approximately 0.314 to 3 decimal place, and s2 will be equals to minus 3.186 to 3 decimal place. Here are some exercises for you to try your hands on at home. And for more insight on this topic, you can check out our Hidden Facts Further Mathematics textbook. You can get the hard copy in bookshops, or if you are interested in the soft copy, you can get it at the website on the bottom of the screen. Thank you.